Hi everyone, today we're going to be looking at MicrobiomeAnalyst, the website, where it can help us process our data for more downstream analyses. So I'm going to be going here to marker data profiling, and here it has some 16S example data sets with 16S read counts using Illumina and human microbiome data from various sites in the body. We're going to go forward. What we find is kind of a summary of what the data kind of looks like. We have average counts per sample. This is pretty good sequencing depth. We have our maximum counts, our total reads across all the samples, and the number of samples in our OTU table, 30, 34. That should be consistent across our metadata table, our OTU table. And this is kind of what our sample looks like. I'm going to download this the summary figure of the reads per sample. This goes the read counts. What we see here at the bottom is the lowest one is about 1,000, which honestly is not too bad. But we'll have to take a look at the rarefaction curves and see if that makes a difference. Now we're going to look at data filtering. Okay, here's where our abundance and prevalence filters come into play. We're going to change this minimum count to 10. That's a pretty good number. And then our prevalence, about 20, should be suitable. We can also edit our samples. We also see here a total of 2,800 low abundance features were removed, and 8 low variance features were removed. And the number of features remaining after the data remains 66. That's the number of taxes we have left. So we don't have to do this low variance filter right now. I'm going to submit. And so we removed that filtering step right there. If we want to edit any of the samples, including discarding any of the samples that, let's say, had very low number of reads, we can do that here, just like this. But we didn't see any that had anything too low. Now we're at the data normalization step. All right, so we're going to focus today on rarefying, whether or not to rarefy. Okay, so we are going to not select rarefying for now, so we can see what our data will look like, and we're not going to scale it at the moment or transform. So we're going to take a look at that rarefaction curve. That'll help us decide how much to rarefy in the end. All right, we'll have that rarefaction curve right here. These are all of the various general explorations that you could do about the data. And then here are more of the downstream analyses that we'll be looking into another time. All right, so let's look at the original data first. And we're not going to group them yet because I want to show you all the samples at once. And then the steps here will just give you the a nicer curve. Okay. All right, this is what we see. This is before we filtered. So we have very high species richness. It goes very high up. And the thing I wanted to point out to you first was the change between this unfiltered and then the filtered rarefaction curve. So here we see that plateauing, but we see very high species richness. However, because the filtering techniques are designed to remove all those rare taxa that drive species richness, which really means just the number of, or not just species richness, but just taxon richness, taxa, it's going to remove those rare taxa. And so if we look at now the filtered rarefaction curve, now we're down to 60, right? And so before we were in the hundreds and stuff. So now we're down to 60, and we see that faster plateau um, much below 1,000, right? So what this really means to us is that, let's say 1,000 is right about here, right? That seems like it should be okay to rarefy down to, because any any more information, any more sequencing depth or sequencing reads after about 1,000 reads in each sample, it's not going to give us that much more species richness, right? And so we can actually take a look at this goods coverage. You can click on that and download it. I have it open right here. And I've just arranged this as a table so that I can organize it by largest to smallest values here. So these are our samples on the right. On the left, we have singletons, so only taxa that appear just one time in one count. And then we have the number of sequences in total, right? So our smallest samples will have only 298 sequences. And then we also have our goods value. So this is representing the sequencing completeness. So, or the sampling completeness, because what this is able to show you, and it goes up to 100%, but the higher number of sequences you have, the closer this gets to 100, which means how many of the true number of taxas did you capture? And so once you, I mean, even here at 296 or 8, it's telling us that 96% have been captured. And we get a little bit closer here as we're approaching 1,000. And so this can also be another variable to help us using this goods coverage value into deciding how much to rarefy. So in this case, we can go back to our normalization. And in this case, so we have these ones around 100, and then we make a little bit of a jump here in terms of the goods value at 1,000. You're going to have to ask yourselves, if you're the experimenters and the investigators, are these samples important, right? Maybe they're not important. Maybe they're supplemental in a way where if you remove them, you'll still have statistical power in comparing your groups, right? So it really depends on how much these samples matter. If these samples matter a lot, what that means is if you want to keep them, you're going to have to rarefy everything down to 298 reads. That's going to remove a lot of data, but for alpha diversity, that would be an important step to do. So in other downstream analyses that you do, maybe rarefying isn't appropriate, right? And so you wouldn't have to do it. But in alpha diversity, it would be highly recommended. And so if we also go back to this plot, I'm not sure why I didn't capture. Let's see here. This is L3S242. Okay, so it actually starts right here. It might have excluded these samples already in the graph, but I would say without knowing how important these samples are, perhaps I would rarefy to maybe 1,095 or 874, discarding these samples. And so I would go back here. I would remove the one, I would move this one. It seems the others have been discarded. I would resubmit my filtering. I would rarefy to 874, let's say. And then submit that. Okay, now let's take a look at that rarefaction curve. Okay, as you'll notice, all of them now have exactly the same length, exactly the same sequencing size, length of the curve, and number of sequences per sample. Okay, and so this is great because we're at the part of the curve where it's really starting to plateau. We're not going to really see much more improvement in that richness if we include more of those samples. So this rarefaction sample should only be applied for an analysis like alpha diversity, and we'll talk about that another time. But thank you guys for joining, and let us know if you have any questions. Take care.